So let's finish this. How far did we get yesterday?
4.1.
We got to 4.
Yeah.
No, we got farther than that, didn't we?
Yeah, we got way farther than that.
That was like 4.7.
Yeah, I thought we were like at 41 or.
We did 4.6. We did 4.7. We did 4.7.
So yeah, 37. Just combine like terms, right? So it's just 11 minus 3i. We did that one, right?
Yeah.
Did we do completing the square at number 41?
Yeah.
Okay. Did we do 45? Go back to the quadratic formula. I think that's where we left off, if I remember right.
Yeah.
All right. All right. You guys remember the quadratic formula? Come on.
Negative b plus or minus square root of b squared minus 4ac over 2a.
Look at you. Air high five. That was a low 5. You could at least give me an air high 5. It's not asking a whole lot for a high 5. And we have to stick with the air high 5. Keep in mind, remember, at this point of your life, in math, you're basically like Batman, right? What makes Batman cool? Guys, what makes Batman cool? It's not the bat. The bat doesn't make Batman cool. It's all his gadgets. Like his utility belt, all his fun little toys, right? Grappling guns and stuff. What makes Batman cool is his belt, his utility belt. You guys are all like Batman. You have tools in your tool belt. You know when to use those tools. You know how to use those tools. This is nothing more than a tool. The quadratic formula is a tool. You got to know how to use it. You got to know when to use it, right? When you are faced with a problem, you have to be able to overcome that. And there's going to be different tools that will help you overcome that problem. Quadratics. When you run into a problem like x squared plus 10x minus 10 equals 0, you got that quadratic you got to solve. You already have different tools in your tool belt to go about solving that problem. Factoring. I would look at this and the first thing I would try to do is factor that. And then I'd quickly go, there's no two numbers that multiply to 10 and subtract to 10. So this is not going to factor. The fact that it doesn't factor, does that mean there's no solutions though? No. It just means we have to have a different tool in our tool belt to solve this problem. Yesterday we did the completing the square method. This would absolutely be a prime candidate for the completing the square method. It would work great. Quadratic formula, also very good method for this problem. Do I care if you prefer the quadratic formula or completing the square? I really don't. Do you need both? No. You got to get good at one of them. At this point, I don't care how you get the answer. Get the answer. That's what I care about. If we're going to do the quadratic formula, what's negative of b? What's negative of 10? Negative 10 plus and minus the square root of b squared would be hundo minus 4. A is 1. C is negative 10 all over 2 times 1. Great. Plug in numbers in. 100 minus, but the 2 negatives would turn that to a positive, so we get what? Negative 10 plus and minus square root of 140 all over 2. We can simplify that because that square root of 140, that's going to break down, right? We'll do that over here. Square root of 140 ends in 10. I always break it down 10 times. Just an easy way to break it down. 10 would be 2, 5, 2, 7. So I got a pair of what? So I got a pair of 2s. So that's going to be negative 10 plus and minus 2 root 35 all over 2. I can divide all 3 of those things by 2, and I would get negative 5 plus and minus just the square root of 35. Bam. Do I care if you use the completing the square method to get that answer? No. I really don't. Guys, there's going to be times this year that I'm going to show you a way to do the problem. And then I'm going to show you another way to do the same problem. I might even show you 3 different ways of solving the same problem. What's your job? Find one that makes sense to you and you can repeat. Like that's really what it comes down to. I don't care what works for you, because what works for you doesn't work for you, it doesn't work for you. You know, you got to find your own path. And is one way better than the other? No, not at all. There's no one way better than other, because, you know, it's kind of like giving directions to your house. When you describe and give directions to how to get to your house, do you give the exact same directions to every single person? Why not? But even if they're coming from the same direction, would you give the same directions to 2 different people that are coming from the same place all the time? Or could you imagine myself saying, you know what, I'm going to give this person these directions, but this person over here I'm going to give these directions? Absolutely. Here's why. Are you familiar with the town? You're pretty familiar with this area, right? Great. I'm going to tell you, go down, you know, I'm going to show you some back ways. I'm going to show you a fast way. My grandma, she never comes over here. She lives in the other side of the state. She rarely comes to this area. I'm going to take her down the expressway and make it the easiest way possible with the fewest number of turns. If my grandma was at my house right now, and first off, it'd be amazing because she died like 5 years ago. But you get the idea. So, sorry, you know, kind of sad. Anyway, if she was at my house and she wanted to go to Meyer, hey, taking the car, going to Meyer, right? Well, how do you get from Yale to Port Huron? Go to Meyer. How would you go? You're leaving right here from Yale High School. You're going to Meyer.
I go straight to the light and up to that one road.
Take that one road, and then take that other road, and then you take that other road.
I live in Emmett.
Okay, you live in Emmett. You're familiar with Emmett. Maybe she goes M19 south and gets on the expressway because that's what she's familiar with. She doesn't know 136 very well. She doesn't like going that way. That way's harder. It's got a lot more turns. She'll get lost going that way. Math is exactly the same thing. The direct route, the fast route, isn't always the best route, because the fast direct route might be the hard route. And only someone that has more math knowledge and is really good at that part of it and can see that, that's a better method. But someone sometimes might need to take the long route around because it makes sense to them, right? One way of doing a math problem is not better than another, as long as you're getting this right answer in the end. Speed is not better. Make sense? All right. Where are we at here? Number 49. So you guys remember how to do these inequalities. We got x squared minus 10x has to be greater than or equal to 0. Anybody remember how to do that? Well, first thing I do is factor that thing. Can you factor that? What's the easy way to factor? What's the simplest type of factoring? Do they have anything in common? Yeah, pull out an x, right? You pull out an x. Everybody always forgets about that type of factoring, right? All right, I want you to kind of take a step back and look at what this is saying. I've got some number, I don't know what this number is, times another number, I don't know what this is. I do know that product, when you multiply them together, has to be greater than or equal to 0. How can you have two numbers multiply together by each other, or multiplied by each other, the product be positive, greater than or equal to 0? How could that possibly be happening? Either this part and this part have to be what? That has to be bigger than 0, and that has to be bigger than 0, doesn't it? Is there any other scenario that could be true? That I have this number times this number, and when you multiply them, it still ends up being bigger than 0. Is there any other scenario that could be in play? They both could be negative. So, or that single x has to be less than or equal to 0, and that x minus 10 also would have to be less than or equal to 0, right? So this could be positive and this could be positive. That would work. Or that could be negative and that could be negative. That would also work. So let's solve them. Well, that's done. X has to be greater than or equal to 0. And x would have to be greater than or equal to 10. How can you have a number that's greater than 0 and greater than 10? Well, it's pretty much just greater than 10, right? Because that becomes kind of redundant. So that's irrelevant at this point. So if the number is bigger than 10, this will work. Greater than or equal to. How about this scenario? Wait, this one's done, less than 0, and less than or equal to 10. How can you have a number that's less than or equal to 0 and less than or equal to 10? Well, it's basically just this, right? Just less than or equal to 0 would satisfy everything. So that final answer is this or that. Will work. Does that kind of make sense how I walk through that? Don't worry, we're not going to do a single inequality all year long. All right, the last one. Did anyone use their calculator to do this one? With the points, and you got to find the quadratic line that goes through them? There's a few different ways of doing this. I strongly recommend the graphing calculator. Does anybody have a TI-86 or 84 on them right now? If you do, take it out, because I want to show you a really nice way of doing this. On the SAT, there's usually at least 3 questions where this comes into play. There are other ways of doing this. There are 3 or 4 different ways of doing this mathematically. Take some time. There's some methods on other lines. I think this could be not a parabola, but it could be a line, those kind of things. There's other methods to solve those. Have you guys ever used these to graph regression lines? You ever done this? I know if you were in Matcher's class last year, you did this. I know you did. I even helped him remember how to do this last year. Okay, so here's how you do this. Turn your calculator on. Turn your calculator on. Come on, calculator. I know you can do this. Don't mess with me. I'm in front of students right now. You're embarrassing yourself. Okay, turn your calculator on. Everything is in the stat menu. Okay? So you press stat. We want to edit our list, so we're just going to press enter on edit. Here's where you put your info in. You got to put it into 2 different lists. Your first list is going to be your x numbers, so -1, 0, and 2. And then in L2, you're going to put the -6, the 7, and the 9. So you're going to put your info in. You can use 3 points for this, you can use 2 points for this, you can use 100 points for this, and the calculator will handle it. Okay? Good so far? Now we want to calculate. So we go back to that stat menu. We got to go over to the calculate button. Now here, if you go down, you can do some stats, but here's where you go down in all of these different regression lines. We can see if there's a line, or what line would hit these 3 points the best. What quadratic equation would hit these points the best. What cubic, what quartic, what linear is another one. Natural log, exponential, there's a power one, there's all these different regression lines are, the calculator will try to connect the dots with any kind of line you want to. What's it asking us to do? A parabola? What kind of equation is a parabola? What is the name of those? Which of these is x squared? Quadratic. A quadratic is what we want. So we press that. Now this depends on how new your calculator is. If your calculator is pretty new, the next screen looks like this. If you have an older operating system, your screen, it'll just say quad regress, and then there's a blinking cursor waiting for you to do something, right? Now, what it's waiting for is, where do you want me to pull the data from? The default is always list 1, list 2. That's where we put it in, right? But maybe you put it in list 3 and list 4. You could change that, right? You could put list 3, list 4. If it's this, and you wanted to change it, you'd put a comma, and then put like L3, comma, L4, okay? So you could change it. If you don't put anything in there, where's it automatically gonna look? List 1 and 2. It also will let you store that. You can store it in, like, if you actually wanted to look at the picture of the graph, you could put like a Y1 there, and it'll put it in the Y equals menu. That way when you press graph, it'll actually draw the line. I don't know if you guys remember that or not. Or you can just press enter and calculate it. You can't look at the equation, you can't look at the graph, but then it'll tell you the answer. It says, I'll write this a little bigger so you guys can see this. Why is this so small? So at the top it says y equals ax squared plus bx plus c. And then it says a is -4, b is 9, c is 7. So if this is what the calculator says, what's the answer? Y equals why does it give us this? That's the standard form. These are the numbers you just write in there. So instead of a, it's -4 x squared, 9x, and 7. The calculator can handle these kinds of things for you. Heck, you know how every once in a while you get that equation, here's 2 points, find the equation of a line that goes through these 2 points? This will do that in 10 seconds. The longest part, the most tedious part, is just putting the numbers in these lists. It doesn't take very long at all. If you get good at that thing, I can pretty much guarantee you at least 5 correct answers on the SAT. Just that, right there. Just that, play around with that. You can do different kind of regression lines. You can see the graph. If you get good at that part, there's usually a few questions that you can do other ways. But here's a fast way for you, okay? Any other questions on this assignment? Awesome.